Welcome to a lesson with Dr. Powell. Let's take a hyperbola. Let's take y squared minus x squared is equal to 1. And let's rotate it by clockwise rotation. Of pi force. Okay, so and then we're going to look at what the equation for that is. And we're going to use complex numbers to do the rotation. And it works out very quickly, easily, smoothly, and nicely. Let's take a look at how this would go. First, what does this look like? So this opens up in the y direction, like this. It's kind of around a unit box here. You're going one up from the origin to the sides of the box. And then the sides of the hyperbola follow these asymptote lines, which are defined by the diagonals of the box. Okay, so we're going to take this and we're going to rotate it that way by pi force and see what we get, what kind of equation. All right. So to perform this rotation, what we're going to do is we're going to be replacing y with something, and we're going to replace x with something, so this equation still holds. What we're going to replace it, we're going to replace it with. So we're going to be rotating here. So what we want is a point on the equation after it's been rotated needs to be, so like an xy value. Okay, this is going to have to satisfy an equation up here. So we're going to take this point and we're going to rotate it to a place over here such that these things satisfy the equation over here. And when we do that, the effect is we get the rotated equation this way. So pretty much what we need to be able to do is we need to be able to take a point right here, xy, and rotate it counterclockwise pi force. And then we plug that, then that should plug into the equation here, and we'll get the rotated version of the equation. So all we need to do is just rotate xy pi force. How do you rotate xy pi force? Complex multiplication is a great way to rotate things. So you multiply it by a complex number that represents rotation by counterclockwise rotation by pi force. And rotation complex numbers are always ones that have a unit length of 1. So unit length of 1, that means, hey, that actually means they're on the unit circle. We know coordinates of the unit circle, especially at pi force even. Coordinates, cosine, sine, I mean, this is going to look like, and if we write this as a complex number, square root of 2 over 2 plus square root of 2 over 2i, that complex number right there, that's what we're multiplying by. Okay, notice that if we want to rotate clockwise, we multiply by kind of the inverse rotation, or we kind of use the inverse rotation here. And whenever we're transforming a graph and we're kind of doing it on an embedded part, it's always kind of in the inverse of what you might think. For instance, if you want to shift something to the left, usually you replace x by x plus 1, right? Hey, plus 1 is like inverse of what you wanted. X value is going down, right? So that's the same type of thing here. So that's why it's counterclockwise rotation. And we're going to just be multiplying by this. All right. So doing that will give us this point up here, which we're going to plug into the equation, and we'll get the rotated version. So let's do that. So if we multiply this out, thinking of FOIL, where first and last gives us imaginary, or gives us real, gives us real, and then outside, and inside the oi part gives us imaginary. Okay, so we get, so for the real part, and okay, so, and the real part actually is going to be that right there. So let's, and that's what we're going to plug into the X value, because that's the kind of the first coordinate. That's how you determine coordinates in complex numbers, is the real part versus imaginary part. So the real part would be square root of 2x, and then we have y times that, but then you have an I times I, which is -1. So it's going to be minus. So it's going to be minus square root of 2 over 2y. In fact, we could just plug that in right here. Square root of 2 over 2x minus square root of 2 over 2y. All right, now over here, what are we going to get? So the oi. So we're going to get, and we just the coefficients is all we need, because I just means it's in the second component. It's going to go there, but the coefficient is really what goes in right there. So we have x times square root of 2 over 2 and y times square root of 2 over 2. So we have square root of 2 over 2x plus square root of 2 over 2y. That's it. That's the equation. Let's simplify it and see if it simplifies nicely at all. All right. So let's do some simplification here. First thing I notice is I see a lot of coefficients out of the same. Wonder if we can do something with that. So we can factor a square root of 2 over 2 out inside of the square, right? And then you square it. So when it comes outside of the square, you're going to get a 2 over 4, which is really 1/2. And you have an x minus y squared. And over here, you do the same thing, factor out 2 over 4. And you get x plus y quantity squares equal to 1, which is just 1/2, 1/2. If I multiply both sides by 2, I end up getting 2 is equal to, and then I can square this, x squared minus 2xy plus y squared, and then I get minus quantity x squared plus 2xy plus y squared. Okay. Next, notice that the x squareds cancel, the negative there, and the y squareds cancel. That's kind of nice. And we have a minus 2xy and a minus 2xy. That's going to be a minus 4xy, right, is equal to 2, which would end up being xy is equal to -1/2. Or in other words, y is equal to -1 over 2x. Wow, that's really nice. In fact, you should recognize this basic graph as a transformation of 1 over x. 1 over x is a hyperbola, and so is this guy. So, but it's like a rotated hyperbola, and this one as well. The asymptotes are right on the axes even, and it's going to come up, it's going to be like, it's just a vertical reflection of 1 over x, and then it's also stretched, but I won't visualize the stretch here, but it's going to look, or actually vertically compressed, I guess, because you're multiplying by 1/2, but nonetheless, it's something like this. So you get this kind of a thing right here. Very nice. And that should make a lot of sense here, because basically what we wanted is we wanted this distance from here to here should be 2, which in the rotated version, because it was 2 before, right here. So that should be present. Hence, this compression should make sense there. Because if it wasn't compressed, this would be, actually, if it wasn't compressed, that would be root like 2. I mean, that would be the wrong, I think it'd be the wrong length. So, or something like that. But okay. So, and we can, but it looks, at least if we did our computations right, I hope we did, we should get this, y is equal to -1 over 2x. And we got that by applying this idea of complex multiplication, kind of fun. and how we could replace things in here. We simplified to get this nice form, and we saw how we could rotate this into that. Thanks for watching.